Hey students, today we're going to look at direct variation versus inverse variation. So, what is it? Let's first look at what it is. Direct variation is a set of ordered pairs with a constant ratio. Okay, it's a constant ratio. And inverse variation is a set of ordered pairs with a constant product. Okay, so ratio means we're going to divide, and product means we're going to multiply. Okay. Now, the equation form. For the equation for direct variation is y equals kx, and k is my constant. Okay, it stays the same. And for inverse variation, my equation is y equals k divided by x. Okay, again, k is my constant. It stays the same. Okay. So, let's look at some examples. For direct variation, an equation would look like y equals negative 3x, or y equals 1/2 x, or even 4x plus 5y equals 0. Because if I was to solve that to get y by itself, it would be y equals negative 4/5 x. Okay? So if you look, my constant here, my k here, is negative 3. My k here in y equals 1/2 x is 1/2. And then in the last example, my constant is negative 4/5. Okay, my k value is in front of m. It's the same as slope. Okay, it's my constant value, the same as slope. Now, let's look at inverse. Inverse, an example would be y equals 24 divided by x. Another example would be y equals negative 18 divided by x. And the last example would be x times y equals 36. Because again, if I was to solve this one, I would get y equals 36 divided by x. Because I would divide both sides by x to get y by itself. So my constant, my k in this one would be 24. Because remember, k is on top of x. K is the top number. For this one, what's my k value? Yeah, you're right. It's negative 18. And then for my last example, y equals 36 divided by x, what is my k value? Correct, 36, because it's the number on top. So for inverse, we're dividing by x. And for direct variation, we're multiplying by x, or constant by x. Now, how do we test for it? How do we test to see if it's direct variation? Well, we check by taking the y value divided by the x value for all ordered pairs. Okay, so we're going to take the y value and divide it by the x value for all my ordered pairs. And that's going to tell me if it's direct. If they all equal the same number, then it's direct variation. And I'll show you some examples in a little bit. For inverse, to check if it's inverse, we check by multiplying x times y for all ordered pairs. Okay, so we're going to multiply the x value times the y value, and if it all equals the same, then it is inverse variation. All right, now the graph. So, let's look at the graph. For direct variation, your graph is going to be a line, and it must go through the origin. Okay? It's a line through the origin. Okay? It has to go through the origin. If it does not go through the origin, it is not direct variation. Pause for a second while the bell rings. And for inverse variation, it's not going to touch the x or the y-axis. Okay? It does not touch the x or the y-axis. And this is called a hyperbola. Sorry. It's called a hyperbola. So inverse variation makes a hyperbola. And the last thing, how do we solve for missing values? Well, we set up, for direct, the setup is y divided by x equals y divided by x. And for inverse, the setup is x times y equals x times y. All right, now let's turn over to the back and let's look at some examples. So we're going to look at direct variation first. So for direct variation, you're also going to see it called directly proportional. Or it will say y varies directly with x. If you see that, that means you're talking about direct variation. Now, let's look at the characteristics of the graph. Okay? One characteristic is it must go through the origin. Okay? It must go through the origin. If it does not go through the origin, it is not direct variation. Another characteristic is it's a line. Okay, it's a straight line. Another characteristic is the y-intercept is always 0, 0. And the last characteristic is the x-intercept is always 0, 0. And remember, x-intercept is also known as your roots, your zeros, or your solutions. Okay, that's not just for quadratics, that's for anything. Those are three other words known as my x-intercept. So an example of a direct function would look like this. okay, because it goes through the origin. Another example could look like this. Okay, as long as it goes through the origin, which is right here, it is direct variation. Now, let's look at the table. To determine if it is direct variation by looking at the table, you're going to take the y value and you're going to divide it by the x value. Okay, so you take your y value and divide it by your x value. So here my y value is 6, so I would do 6 divided by my x value, which is 1, and that equals 6. Then here, I would do 12, my y value is 12, and my x value is 2, and that equals 6. Then I would do the next one. I would do 18 divided by 3. Again, 18 divided by 3, that equals 6. And the last one is 24 divided by 4, and that equals 6. Since they all equal, all of these equal, it is direct variation. Okay? They all have to equal. If one of them does not equal, then it is not direct variation. So they all have to equal. And then our last example. If x and y vary directly, find the missing value. Well, remember, from the front, to set up, we do y divided by x equals y divided by x. So, I'm going to set it up. I have y divided by x equals y divided by x. Now, just make sure you put your y and x values together. So, for the first one, for the first ordered pair, what's my y value? Well, it's 18. So I have 18 divided by, what's my x value? Negative 10 equals, over here, what's my y value? Well, it's my unknown. I don't know what it is, so I keep it as y. And then, what's my x value? 5. Now, you just solve. Do your butterfly method, cross multiplication. So, I'll have negative 10 times y is negative 10y equals 18 times 5, which is 90. And then now I'm solving to get y by itself. So to get y by itself, I'm going to move the negative 10. So I'm going to divide both sides by negative 10. That cancels, and y is left with negative 9. So my missing value was negative 9. All right, now let's look at inverse variation. Another way you will see it is it will say inversely proportional, or y varies inversely with x. Now, the characteristics is it never touches the x-axis or y-axis. Okay, it is never going to cross the x or y-axis. Okay, so this is an example. It will never cross the x and the y-axis. Okay, there is no x-intercept. Another characteristic is there is no y-intercept because it's never going to touch those. And then the last intercept, it does not make a line. Okay, it does not make a line. It's called a hyperbola. Okay? Now, let's look at the table. How would we know if it's inverse by looking at the table? Well, in this case, we're going to take the x times the y. So we're going to multiply x times y. So here, my x is 2, so I take 2 times 12, and that gives me 24. And then I do the same thing for the next one. 3 times 8, that gives me 24. 4 times 6, that equals 24. And then the last one is 6 times 4, that equals 24 as well. Again, when you multiply x times y, if they all equal, then it is inverse. Okay? They all have to equal when you multiply. Remember, inverse is multiply. Okay? And then the last example is, if x and y vary inversely, find the missing value below. Well, remember from the front, our setup is x times y equals x times y. So now we plug it in. So my x value on my first point is -9 times my y value, which is 4, equals, my x value here is unknown, so I don't know it, times my y value, which is -12. So now just solve. What's -9 times 4? -36 equals, what's x times -12? -12x. Now, how do I get x by itself? You are correct. I divide by -12. And so x equals -36 divided by -12 is 3. So my missing x value was 3. All right, take notes, understand this. We'll go over it some more on Tuesday. And on Tuesday, it will be a grade. Have a wonderful night, or a wonderful day, actually.